All right. Hello, everyone. Welcome to another webinar brought to you by the C45 Quality Association. My name is Tom Ulanowski. I'm the chair of the association as well as your host today. And before we get started, as always, just a few announcements and some housekeeping items, and then we'll get going right away. For those of you that don't know, we're the C45 Quality Association. We're quite unique as an industry association in Canada. We're non-for-profit, we're membership-backed, we're not corporate-backed, and we were started a few years ago now by some industry professionals that thought it would be very important for, very important kind of players in the industry, those in the quality, regulatory, and lab testing sector, to have a unified voice, and that's what we strive to do. We represent around 100 members across Canada in various quality testing and regulatory roles. And we do a number of things. Typically, we put on events such as this, where we kind of provide a platform for our guests to kind of discuss various important topics, whether those are people we invite from the government and the regulatory side, the lab testing side, or the industry. But today we're actually focusing on the kind of academic portion of the space. We also plan in-person events. We've had kind of a lull in that because of COVID, but I am very happy to announce that we are actually putting on a quality summit, an in-person quality summit this summer in June in Hamilton, Ontario. So I'll talk about that in a second. We also typically, as an association, engage with various regulators such as Health Canada and the provinces. Typically, we do that in writing. We just did a submission a few weeks ago related to some kind of release criteria and lab testing criteria drafts that we wanted to provide feedback on. So we do that a few times a year. We also meet with Health Canada a few times a year. So that's great. We kind of distill our concerns and our members' concerns and the industry's concerns and kind of put that together in a constructive format so that the regulators can kind of see the issues that we're having as an industry and act on them, or hopefully act on them anyways. So if you want to know more, check out our LinkedIn, check out our Twitter. Our YouTube channel has a pretty big archive of all of our past events. So we are recording this as well. So that'll be up in a few days after this event is done. And so, yeah, check us out at c45association.com. Sign up on our mailing list so you kind of are aware of these future announcements, and consider becoming a member. Memberships start at $49 a year for students. They get you access to our portal. They get you access to members-only events. And in this case, they'll also give you a big discount on the Quality Summit. So just a few notes on that. It's been a few years since we've had a summit. In fact, this association has basically started because of a summit we put on in Winnipeg, about 5 years ago now. And so again, because of COVID, we've had to kind of take a break. We did some online stuff, but we decided that now's the time to kind of get everyone together. A lot of people have been asking about this. So right now we've secured a venue on June 7th, 2024. So in about 6 months from now in Hamilton, Ontario. Why Hamilton? It's close enough to Toronto, the center of the universe for most of Canada. So it's going to be accessible to a lot of people. There's cheap flights in the areas. There's access via public transportation. And we're just trying to make it as kind of efficient and cheap for people to attend as possible. So we're looking to gather about 200 people from the government, federal and provincial, from industries such as labs, processors, cultivators, academia. Basically, put people in a room, have some panels, have some discussions, have some kind of working sessions to discuss the big issues of the industry today and ways that we can tackle them. And tickets are starting right now at $99 for the day. It's a one-day event. What that gets you is breakfast, lunch, and snacks and coffee throughout the day. We're looking for speakers. We're looking for volunteers, ideas, sponsors, all that fun stuff. So if you want to know more, check out c45summit.com. And there's links to buy tickets right now. Or if you want to reach out to be a sponsor, we'd love to have you. And also, you can email the team at c45association.com if you have any questions, or you can always shoot me an email, tom@c45association.com. So check that out. Okay, housekeeping. before we get started here, and I'll introduce Sarah. This webinar is being recorded and it will be available on our YouTube channel. So if you are concerned that you won't get everything in one take, you can always reference that. So that's great. We will have plenty of time for questions and answers at the end. Please use your Q&A function of Zoom, get all the questions in there, and we'll kind of take them in order and prioritize them. So please do that. If there's any technical issues, please let us know in the chat. We'll be monitoring that. And during the Q&A session, you can also raise your virtual hand and we might open up your mic and we can have a little discussion there. So without further ado, I would love to introduce our first guest here, Dr. Sarah MacPherson. Sarah is the program coordinator at NSERC's QAQC for cannabis production. And so I'd like to kind of offer her the floor now and have her introduce the program as well as our speakers for today. So good luck, everyone. And thanks, Sarah, for organizing this with me. Appreciate it.
And thanks to you, Tom, for the invitation. Good morning and good afternoon to everyone in this Pan-Canadian audience. It's a pleasure today to highlight our program and some of the top researchers that have come out of this. Those from the University of Ottawa, the University of Saskatchewan, and McGill University. If you're curious about what our program is, just 1 second, I'm having the QAQCC, or that sort of mouthy acronym, actually stands for Quality Assurance and Quality Control for Cannabis Production, Products, and Training. This is what is considered an NSERC CREATE program, so a collaborative research and training experience that focuses on research coming out of graduate students' labs or research programs, and they're typically enrolled in master's or PhDs at these 3 participating universities. This is a unique type of CREATE, the industrial stream CREATE. So this means that we collaborate often with industrial entities or corporate entities. So whether they might be licensed producers in this case, analytical labs, ancillary services, maybe lighting or fertilizer companies. This is what we do. And the liaison often happens through student internships. So many of the researchers in our program study cannabis all along the supply chain, whether it might be production or cannabis cultivation, post-harvest handling and processing, extraction, analyses, formulation, so anything transformative, and of course, QAQC. So we might have people that are looking at mycotoxins, working alongside Health Canada. We might have people looking at the beverages that are coming out of this industry. So today, it's a pleasure to introduce my students, and I'll get to that in a minute. But overall, the goal is to work alongside industry and government to improve quality and safety for consumers. So what is our network? We are overseen by a program committee. So this acts as almost, it's analogous to the board of directors. So on this program committee is a director from Health Canada, industry representation, and academic representation. And at the heart of this program is really the graduate students. So in the beginning of this program, we really focused on masters. Many of them transitioned to PhDs and have stayed there just because of the interest and the kind of growing interest in cannabis research in Canada and around the world. And we also provide awards to undergraduate students that might be coming up through the pipeline, also interested in cannabis research or, of course, food science, controlled environment ag. Again, we collaborate heavily with industry. So whether they're producers, analytical labs, or anything else along the cannabis supply chain, our students spend an internship period with these people, learning sort of the backbone of the industry. We also have interns at Health Canada. They've been a great collaborator and supporter of the program from the start. They provide GPB training every year to our new cohort. Again, that one of their directors sits on our board of directors or program committee. They also come to our symposium every year, which I'll talk about shortly, and they share their findings. So on the academic side, we have 9 principal investigators and at least a dozen collaborators. They work together in supervising the research for these graduate students. And I think I'll keep it at that. If you have questions for me afterwards, I'd be happy to answer that. The overall aims and outcomes of the QAQCC are to produce job-ready graduates. This was a goal from the very start, recognizing that training might help this nascent industry in Canada as recreational cannabis use had been legalized. And clearly, as we've come to realize, there are great gaps between academics, industry, and government, and this hopes to bridge some of these gaps through collaboration. Ultimately, we are academics. We generate unbiased data, methods, and standards, and we share knowledge. So part of this and part of our grant and our mandate is to share this at our symposium. So this is a shameless plug to attend our symposium in June, just a few days before yours, Tom. If you'd like to learn more, you can certainly visit our website. We highlight research from industry, from academics. Everyone is welcome here. On to next steps, I'd like to introduce our first researcher, Vincent Desaulniers Brousseau from McGill University. The floor is yours, Vincent.
Okay, thank you, Sarah. Thank you everyone for taking the time to be here today. I know everyone's busy, so appreciate your participation. So anything I'll be presenting here should be published relatively soon with hopes of passing through reviews. But so I'm going to be talking about the environmental impact of outdoor cannabis agriculture. And I apologize because I'm a bit sick today. And I think Sarah needs to do the transition slide. So I don't know, because I don't have, I can't change slides at the moment. So.
Sorry, Vincent, it's just like not taking my prompt.
Okay.
There, we're good.
Okay,
we're good to
yeah.
go.
Thank you. So a brief overview of the presentation today. So I'm focusing on the environmental impact of fertilizer use. Today we'll be focusing on a fertilizer response trial that we did over 3 years outdoor grow experiment. Then I'll go over a life cycle assessment we used to measure the carbon footprint, and then conclusions and perspectives of what's next. So what do we know so far about the environmental impacts of cannabis agriculture? So outdoor is associated with water displacement, erosion, land fragmentation, wildlife habitat threat. Those are all from Californian studies. In Canada, there's no, well, I mean, from my knowledge, there's no studies on the outdoor production, but there's 530 hectares of production in Canada. That was in 2023. Carbon footprint is unknown, but for indoor production, we know there's a very high CO2 emission between 2,000 and 6,000, and there's about 165 hectare of production. Next slide, please. Okay, so cannabis fertilization, why did we look at that? Well, it's mostly because it's less than 1% of published articles on cannabis, mostly focusing on medical aspects or extractions or other. But we do know it affects yields and it gives more biomass. So usually when you put more fertilizer, you get more biomass, but there is this concept of dilution effect, right? So you get bigger plants, but you don't increase the THC content, which is for some people very interesting because, you know, if you do extract, you're looking at your THC count. It's more important than, you know, the flower yield. If you have big flowers, which have very poorly concentrated in THC, it's also of less value for customers because we know customers prefer higher THC content. I know there's the magic 22%, but there's also people who aren't honest about their THC content, but that's another subject altogether. So that's why we decided to do a fertilization study. Next slide, please. But then we combined the fertilizer trial data with a life cycle assessment, which is very helpful because it integrates all the supply chain. So from transport to raw material extraction and processing to up to use and discard of the product. It's a ISO recognized protocol, so you can publish with these data. There's guidelines for international cooperation. You can also identify hotspots, so which steps of the production can be improved. There's information for policymaker and also marketing potential for producing eco-labeling or, carbon credits or other means. Sorry, next. Okay, so this is an outlook of what the experiment we did. So we modulated the inputs of an outdoor grow experiment by modulating fertilizer, potting media, and agricultural practices, and we measured the outputs in yield on a THC basis, dried flowers, and also externalities, so resource depletion, greenhouse gas emission, and ecotoxicity. Next slide, please. So there's going to be some animation, Sarah, in the next slide. So you can click, so the cannabis fertilizer LCA, we're going to use a functional unit. That's how they say in LCA. So a functional unit is so you can compare between two products. So for example, for cannabis, other studies use 1 kilogram of production, but we're also going to be looking at THC output, so masses of cannabinoids produced. Sarah, you can click so fertilizer input and output yield flower and THC. You can continue clicking, Sarah. There's going to be a bunch of animation. So yeah, I spent a lot of time animating these slides. Not my first time showing this. So we use two types of fertilizer. One is a balanced, 14, 14, 14 NPK. Those are macronutrients. They're the most present in the plants, and we focused on nitrogen and potassium. So here you see the 6 treatments we use. So we use 3 levels of nitrogen, so low, medium, and high, and every level had a 2 treatment with lower doses of potassium or higher doses of potassium. So 6 treatments, low, medium, high. Plus is for more potassium, and minus is the same content, so the same qualities of nitrogen and potassium. Then we harvested the height, mass, and THC content. And so this was done on 3 different years. So we compiled the data, which we can show what is how the plant responded to fertilizer. So here we see 4 graphs, and evidently the more nitrogen you put on, so the x-axis is the quantity of nitrogen fertilizer, and so the dashed line is the lower potassium treatment, and the filled line is higher potassium. So you see, if you're just looking at the plant, potassium doesn't seem to be helping in any noticeable way, right? So higher potassium treatment is similar or even lower than the lower potassium treatment for fresh mass. So that's a whole plant fresh mass. If you're looking at figure A, figure B, you see stem diameter, no significant change. Figure C, height also, potassium doesn't seem to be helping. And dry flower yield, you don't, if you're just looking at this graph, you could say, oh, you don't need potassium, a high amount of potassium, because the highest producer plant was just a lot of nitrogen and not necessarily needing any high amount of potassium. But then if you look at the next set of figure, and Sarah, you can click just one time. Okay, so highlighting these 2 data points, right? So lower nitrogen content, but higher potassium had a significant increase in THC content, right? So if you're using low nitrogen and high potassium, you're going to be having an increase in almost 4% of THC, total percent, or 30% relative increase. And for one plant, you're going to get maybe 2.5 grams of THC for one plant versus 4 for a high nitrogen fertilizer recipe. So then we continued the analyses by finding this. So we wanted to compare the low nitrogen and high potassium treatment that you see this purple arrow that highlights this treatment with the high nitrogen and low potassium treatment, so big plants with less cannabinoids. So if we continue through the slides, so this was across all treatments, we saw this negative correlation between fertilizer and content, which is seen in leaf and content. So the more nitrogen you put, the less THC in your flower you're gonna get. So this just highlights, and this was previously seen in other articles. So the more N input and the more N uptake the plant gives, the less THC it produces. So THC doesn't have any nitrogen in it. It's a molecule. It's just a carbohydrate. So if you put nitrogen, the plant is going to produce molecules with nitrogen. And because THC doesn't have nitrogen, the plant stops or decreases its production of nitrogen. So you can see in our study, most plants at harvest were technically in deficiency. So they were between 0.7 to 2% leaf N content. But that's because we did an extensive flushing period. Flushing is when you stop giving fertilizer. Our fertilizer was incorporated, so we just put it in the potting medium at the start of the season and we stopped fertilizing. So it's a controlled release throughout the growing season. And it's known that at the end of the season, there's not a lot left. So there's an extensive flushing period in our study. Next slide, please. Okay, so then, Sarah, you can just continue clicking it. So this is the two options we have. So there's the business as usual scenario, the blue lines where you put high input and you get, 40 grams of flour and 4 grams of THC, or you put low input and you get 20 grams of flour, 2.5 grams of THC. So you're pushing this proportionally, you're pushing THC. Sarah, you can continue. So here's the animation too. So because we know 1 kilograms of potassium fertilizer is much less CO2 intensive than 1 kilograms of nitrogen fertilizer. Nitrogen is synthesized by fossil fuel combustion in the Haber-Bosch process. I won't go into too much detail, but using a software OpenLCA, we were able to measure how much fertilizer associated carbon footprint was for cannabinoid. So if we're looking at the next slide, so this is only for the fertilizer process, so production. And if you could just go back one time, Sarge, I'm just going to focus on, so this is for the production of 1 kilogram of flour. If you're using a high input, high fertilizer input, you're getting up to 3.54 kilograms of CO2 for 1 kilogram of flour. And there's a 36% reduction if you're using a low input fertilizer. So, and then if we look at the other metric, which is cannabinoid, this reduction is almost half, right? So you're halving your CO2 footprint by using a lower input fertilizer. And then, Sarah, if you click another time, there's the price comparison. So these are spot price from, fertilizer. I think they're from last year, so they might be outdated. They could be used an update, but I'm sure the trend would be seen that, you can almost have and even 1/3 of the cost when you're using a lower input. So you're really pushing that THC production by using a lower fertilizer input, and that has a direct effect on, price, operational expenses. So discussion and that's good. So is kilogram of dry flour a relevant unit? So other studies have used it, but then we show here, if you're gonna see a significant increase in cannabinoid production, you got to keep that into account. And in Canada, 30% of sales are extracts or vaping cartridges or whatnot. So for these producers that really focusing on more THC equals more units sold, then that's a more relevant functional unit. So 30% THC increase in the lower input. So there's the dilution effect, but there's also a low N stress response. So when there's no more nitrogen, the plant is going to produce more THC, and potassium seems to be very helpful in maintaining the enzymatic machinery for cannabinoid production. Low nitrogen fertilizer decrease both greenhouse gas emissions and operational expenses. So that's a win-win situation for modern industries. And also the importance of flushing periods. So if you're not flushing appropriately your plants, right? So at the end of the growing cycle, if you're not, taking out the nitrogen, you might be losing on that natural productivity that the plant has. So that's it for me. If you have any questions,
We'll
I'd be
leave the
more,
questions
yes.
to the end.
No,
Yeah.
yeah, that's exactly. I'll be there after the other presentation, and I'd like to thank you for your attention.
Thanks for sharing your work, Vincent.
No worries. Oh yes, and I'd like to thank everyone who helped me through this and all the funders and everything. Thank you.
Our next researcher is Dr. Philip Addo, also from McGill University, focused on post-harvest processing. Go ahead, Philip.
Yes, thank you very much for the introduction. So, as already mentioned, my name is Philip Wiredu. I'm currently a postdoctoral student under the supervision of Professor Mark Lesford at McGill University. I'm also a consultant at Crop Heaven. It's an indoor farming consulting company. So today I'll be presenting on the post-harvest processing for cannabis. So as we already know, post-harvest basically refers to all these steps you have to take after the crop is harvested. The post-harvest losses can be defined as the degradation in your quality and also the quantity of your crop after harvest to the consumption. So over the years, roughly 5 years, we've been doing a lot of studies on the post-harvest processing line for cannabis. But for this presentation here, I would focus on the storage systems, the drying techniques, and lastly, the extraction systems. We can move to the next slide. So depending on the structure of your cannabis facility, some producers are able to dry their biomass immediately after harvest. Others would have to store their biomass under the right conditions to prevent the growth of molds and other spoilage organisms. So based on this here, we decided to investigate the effects of pre-freezing your biomass at different temperatures, and specifically how the pre-freezing affects your trichome structures and the drying kinetics, the color, and also the retention of your cannabinoids and terpenes. So we used hop as a model plant for cannabis. When we started this project 4 or 5 years ago, we didn't have a cannabis research license. And we all know that hops and cannabis both have similar physiological and chemical structures. So what we did was we pre-froze our biomass at -20 degrees Celsius, -80, and also used liquid nitrogen, which is around -146 degrees. So looking at the graph here, A and B represents the lupulin glands of fresh hops, fresh harvested, no pre-processing being done to it. So as you can see from this graph here, pre-freezing caused significant structural damages to our glands in hops. However, looking at C and D, which were pre-frozen at -20 degrees Celsius, there were major structural damages. And this can be attributed to the slow pre-freezing rates, which cause large ice crystals to be formed. On the other hand, when pre-freezing was done at -80, which is E and F, and using liquid nitrogen, we didn't observe much structural damages, rather the glands imploded. This we can know it's attributed to the pre-freezing rate, which was very fast, which caused small ice crystals to be formed. Next slide, please. So similar observations were made for cannabis. So pre-freezing caused the trichome hairs to fall off and also the trichome stalks to wrinkle. Looking at when we did the freeze drying on them, we noticed structural damages to the trichomes. So we now know that these damages could make moisture and also cannabis oil readily available for extraction and also for drying, thereby reducing your extraction time and your drying time. Next slide, please. Yes. So we observed that pre-freezing your biomass, even before hot air drying at even 50 degrees Celsius, can actually reduce your drying time by 22%, which is very significant here. Looking at the pictures on the right, just by you pre-freezing your biomass before even drying can also help preserve the color of your biomass. Next slide, please. So the take-home message here is that pre-freezing is a very important step. It can help you extract more oils and also reduce your drying time. As shown, the SEM analysis showed that pre-freezing causes structural damages to the cellular structures of our cannabis biomass. Pre-freezing can also help reduce your drying time and also help preserve some of the secondary metabolites present in cannabis, which I'm going to show in subsequent slides. And lastly, we can reduce our drying time to up to 86%. So now I'm going to talk about the drying of cannabis. So we all know that drying is basically a thermodynamic process which involves the heat and mass transfers. We know that most farmers in the cannabis industry use the air or the hang drying system where they basically hang their cannabis biomass to dry them on drying racks. The problem with this system is that it takes forever for you to dry your cannabis biomass. You also need a very good HVAC system to ensure proper airflow and humidity and temperature controls. Lastly, you also need to invest in a very large space to prevent overcrowding of your biomass, which can lead to improper drying, which can subsequently lead to the growth of molds and other spoilage organisms. So over the years, different modern systems have been developed. For this project, we focused on the freeze drying system, the microwave system, and also the hot air drying system. So just like any modern new system, there are some few challenges with them. So we know the high operational costs associated with them. Second, you also need skilled personnel who have knowledge on how to operate these systems. Third, the high temperatures used by some of these modern systems can lead to the loss of some of your secondary metabolites and also can cause some high total color changes. The last one here, which is actually my favorite, most of these systems are not equipped with sensors for you to determine the end of the drying process in real time and rely on personnel to take samples during the drying process to determine how much moisture is present or water activity, since we learned that yesterday. So they either use the moisture analyzer or the mass balance to determine this. Not only can this lead to under and over drying, it can also cause some cross-contamination there. So some novel prediction sensors have been developed to help determine this end of the drying process. We know about the e-nose and we also know about the computer vision. So looking at the e-nose, it only gives you information about the volatile compounds which are leaving during the drying process, but you have to frequently clean your sensor to prevent saturation of these sensors. Computer vision only gives you information about the exterior parts of your biomass and not what is actually going on inside. So with the help of a master student, we were able to develop a relative humidity sensor to help determine the end of the drying process in real time. So we decided to test this concept in an industrial setting. So we placed sensors to measure the temperature and also the relative humidity in the airstream of a drying room and also the conditions around a cannabis bud. So as you can see from the graph on the, sorry, I thought I was controlling it. The graph on the right, the red line here represents the temperature of the airstream in the drying room. The black line here represents the temperature of the cannabis bud being dried. The ash or the gray line represents the relative humidity of the airstream in the drying room, and the yellow or the gold line here represents the relative humidity of the cannabis bud whilst it was going through the drying process. So as you can see, at the beginning of the drying process, the temperature of the cannabis bud was very low because it was using the energy to evaporate the water. It basically acted like the skin of our skin during summer when we sweat. During the drying process, as the moisture was being evaporated, the temperature of the cannabis bud became similar to the temperature of the airstream. Looking at the relative humidity of the cannabis bud was very high at the start of the drying process, and this is because of the presence of moisture. But towards the end of the drying process, we saw that the relative humidity became similar to the set relative humidity of the drying room. So at this point, there was no loss or gain of moisture by our cannabis bud. Hence, we deemed that to be the end of the drying process. So we decided to further test this theory using a controlled drying system, and we decided to use the freeze dryer. We also wanted to know where exactly should these sensors be placed in this drying unit. So I decided to use 3 different sensors. So the first one is sensor A, which was placed in the headspace of the drying unit, just to measure the relative humidity in there. The second sensor, which is sensor B, was placed 0.05 meters away from the drying tray to measure the relative humidity around this tray. The last sensor, which is sensor C, was placed near a representative bath in the center of the drying tray to measure the relative humidity around the sample. So we did some few preliminary studies, and it showed that when the system was turned on with no sample in the freeze dryer, the relative humidity quickly reduced to 0 and stayed at 0 throughout the whole process. And when we turned the vacuum off and turned it on the machine, the relative humidity went back. So this here served as the baseline for the state. Sorry, next slide. Yes. So based on this preliminary study, I concluded that the exponential reduction of my relative humidity here was as a result, when I had a sample present in there, was as a result of the reduction of the moisture or the evaporation of the moisture in my freeze drying units. However, the results only showed that only sensor C was actually recording the actual changes in my relative humidity during this drying process. You see, for sensor A and B, when even I had a sample in there, the relative humidity quickly reduced to 0 and remained at 0 throughout the whole process. I did some few modeling studies, and it showed that there was a very strong correlation between the changes of the sample mass and the changes in the relative humidity during this drying process. And this confirmed to me that relative humidity here can be used to determine the end of this drying process. However, the sensor needs to be placed in the center of the drying tray and also near a representative bath. Next slide, please. So we further wanted to reduce the drying time and decided to use the microwave-assisted hot air drying system, the one on the left. The first problem we faced with the system was that there was a lot of losses of terpenes and some of the other volatile molecules due to the high temperature being used there. So we decided to have a condensation coil and also connect a cooling system to it. And this was to help trap any of these volatile compounds leaving our biomass during the drying process, which could be used to rehydrate our sample. We were able to use the system to reduce the drying time to about 35 minutes to 40 minutes, which was really significant. And the losses were also reduced too. Next slide, please. So looking at the fun stuff, the cannabinoids, the red bar here represents the fresh, which hasn't been processed. The yellow or the gold bar represents the pre-frozen samples, which also haven't been processed. The green represents the microwave-assisted hot air drying samples, and the blue represents our freeze-drying samples. So this result here shows that pre-freezing increased the concentration of our cannabinoids by liberating the trapped cannabinoids due to the structural damages caused to the trichomes, which I showed earlier. The results also show that there was an increase in the decarboxylation of THCA to THC in the microwave-assisted hot air dry samples due to the high temperature used. So based on these results here and other results which I couldn't show due to the time constraint, freeze drying seems to be a better drying system as there were no significant losses to our major cannabinoids. Next slide, please. So to summarize the drying studies, relative humidity can be used as an indicator for the end of the drying process. However, the sensor needs to be placed near a representative bath in the middle of the drying tray. Freeze drying is a better drying system compared to the microwave one, since it helps to retain most of our cannabinoids. For industrial purposes, we also did some modeling studies, and we found that our data fitted perfectly the page and logarithmic models, so they can be used for industrial scale purposes. So I'm going to briefly discuss some of the extraction studies which we did. So for this study, I basically evaluated the effect of independent variables such as the sample to solvent ratio, my extraction time, and also the extraction temperature, and lastly, the ultrasound duty cycle on independent variables, which were the yield of cannabis oil and the concentration of cannabinoids present in the extracts. This was done to help determine the optimal conditions for extraction using different extraction systems. So what I did first was I pre-froze my samples, then I cryoground these samples. So 3 different extraction systems were used here. We used the cold ethanol extraction. We didn't have the cold ethanol extraction, but what we did was we retrofitted another system to simulate the same conditions. We also used the ultrasound assisted one, and we used the microwave assisted extraction unit. These systems were all evaluated and we compared them afterwards. Next slide, please. So after the extraction process, I filtered the extract using the vacuum filtration system there to remove any residual biomass present in the solvent. I also used the rotary evaporator to carefully remove the extraction solvent in order to get my crude cannabis oil, which is showed on the far right. For this study here, I used ethanol to be my extraction solvent because that's what it's used mostly by the cannabis industry. Next slide, please. Yes. So just to highlight some of the major results, for cold ethanol extraction, reducing the sample to solvent ratio significantly increased my extraction yield. This was because of the increase in the surface area of the biomass. Looking at the graph on the right, I did some few statistical analysis and it showed that there were no significant differences between the extraction yield for cold ethanol extraction at -20, -40, and even at room temperature. So one would ask, why should I then do my extraction at, why shouldn't I just do my extraction at cold using room temperature rather than using cold extraction, which is -20 or even -40, because then I'll be able to save on the energy which is required to maintain these cold conditions. You see, when you do your extraction at room temperature, you basically increase the extraction of heavier molecular compounds such as your waxes. And these compounds are not needed, hence you require a winterization step to carefully remove them. But when you do your extraction at cold conditions, you limit the extraction of these heavier compounds, hence no winterization step. So in the cannabis industry, if you are able to remove a step from your processing line, that is you saving money there. So comparing the microwave assisted extraction and the ultrasound, we observed that the ultrasound was a better extraction system as we had 14.4 more oil using that system. And there were similar observations when we looked at the various major cannabinoids where the ultrasound extracted more cannabinoids than the microwave one. So this here can be attributed to the oscillating sound waves of ultrasound that produces acoustic cavitations, which increase the penetration power of solvents into the sample's metrics, thereby facilitating the extraction of our oils and also our cannabinoids. So to summarize, the optimal conditions here for ultrasound and microwave was a sample to solvent ratio of 1:15 for approximately 30 minutes at 60 degrees Celsius. For cold ethanol extraction, the cannabis to ethanol ratio of 1:15 was also ideal for 10 minutes extraction time. As already mentioned, ultrasound gave a better yield compared to the microwave one. After the study, we realized that a second extraction process may be ideal for your residual biomass to help improve your extraction rates. However, some cost analysis need to be done to evaluate the step to see if it's going to be profitable or not. Next slide, please. So lastly, I just want to quickly present our current study. So we've gone back to cultivation studies. We do believe that for us to have a very good cannabis product, we need to understand the effect of light on photosynthesis and the other growth parameters. So here we want to know if what wavelength should account to be photosynthetically active, We also want to discover if there is a synergy among different wavelengths. So say if I'm using blue light, or I'm even using red light, or combine the two at different ratios, what effect does that have on the plant? We also want to define the potential variation, if that exists, between the rate of photosynthesis between the leaf and also the whole plant. So one would ask, what is the benefit of this to the industry? Is to just develop or establish an ideal wavelength and intensity to maximize photosynthesis and also increase the secondary metabolite accumulation. So I know this was a very quick recap of most of my studies, but for you to learn more about it, we have some few publications here. You can also contact me via LinkedIn or via email if you'd want to further discuss cannabis. I'd like to say a very big thank you to my lab mates. We do have a very big lab, which is divided into 3 major groups. We have the controlled environments group, the porous concrete, and the cannabis research group. Next slide, please. Also want to say a very big thank you to our industrial partners, ESCA, Bloom Labs. They've been really good to me, helping me with my cannabinoid analysis and also training me. Also to the National Research Council, they've been really good to me too. And all the major people you see on this slide. Thank you very much.
It's time to present our last researcher in the QAQCC, PhD candidate Corrine Dobson at the University of Ottawa. Go ahead, Corrine.
Hi, thank you all for attending this session today. So yeah, I'm Corrine. I'm participating in the QAQCC program under the supervision of Dr. Corey Harris at the University of Ottawa. And my project is looking at cannabinoid content in cannabis beverages and the related risk of CYP450 liver inhibition. All right, so on to the next slide, Sarah, please. Thank you. Yeah, so my area of research as it relates to QAQCC concerns cannabis edible products, which are a relatively new legal form in which to consume cannabis. So they were introduced for legal sale the year following cannabis legalization in Canada. And the problem my study is addressing is looking at this wide array of newly available and diverse products that are easily accessible to the public. So we have a whole branch of new users using those recreationally or perhaps alongside prescription drugs, and then kind of investigating this understudied area where there's not much research or much known about the metabolism of cannabis edible products. So on to the next. Yeah, so in terms of cannabis edibles versus traditionally smoked cannabis, we see from a recent study, recent cannabis survey, the 2022 Canadian Cannabis Survey, we see improved attitudes towards consuming cannabis edibles as this being a favorable form compared to other modes of consumption for any drug. Anyone would rather eat a brownie compared to injection or inhalation, the side effects of which have been shown to be negative, especially with vaping in recent years. So going forward, my project in particular is looking at cannabis beverages because we've seen an increase in both availability and product diversity as they're an easy product to produce and provide a nice alternative in social settings for alcoholic beverages. So like any cannabis product in Ontario, a single beverage cannot contain more than 10 milligrams of the cannabinoid THC, but there's no limits on the amount of CBD content. However, with a drink volume changes, which can create different concentrations of cannabinoid that can be delivered in a single dose. And this is also interesting given recent discussions surrounding new limits or proposing new maximums per packaging for cannabinoid products. All as well, because these products are they're consumed orally, this provides an additional challenge, as we can see in the next slide. So when you think of cannabis, you think of typically smoking it, and most users are familiar with the timeline associated with smoking a joint. The Canadian Cannabis Survey shows that while smoking remains the most common method of consumption, we see edibles are increasing in use. And While typically effects are felt from smoking within minutes as they cross the blood-brain barrier, edible cannabis effects can range between 40 minutes and up to 2 hours, with peak duration of events not reaching their peak until several hours after ingestion. So this can be variable, this could be slow along with digestion. As well, like for cannabinoids, like any exogenous compound, these will have to first undergo first-pass metabolism, digestion, and absorption into the liver, which is where my area of research comes in, looking at the CYP450 family of enzymes, as this is of particular importance because they're responsible for the majority of metabolism of not just cannabinoids, but of all exogenous compounds. So in the next slide, we have a metabolism pathway of THC. And note that cannabinoids are both substrates for this pathway, as well as potential inhibitors for these enzymes. So previous literature has identified CBD in particular as a major inhibitor for significant CYPs. THC has also been shown to have some modulatory effects, but not to the same extent. So the risk here occurs when cannabinoids are being consumed orally. This increases the potential for drug interaction. So this means that drugs that are taken concurrently may not be able to have the converted to their active form or excreted properly, creating a higher or lower dose than expected. So on my next slide, the main objectives of my work are to investigate the potential for these cannabis beverages to have any interaction with this family of enzymes and assess their safety based on these findings. So the two main hypotheses of these work are that the cannabinoid present in the beverages will be the main driver of any inhibition, and as well, due to the complexity of these beverages containing extracts of cannabis compared to a pure cannabinoid alongside the presence of other ingredients, we would see more inhibition compared to an equivalent amount of just isolated cannabinoids. So moving on to test this, we collected a range of high THC and high CBD beverages through the Ontario Cannabis Store, as well as local beverages. We saw a wide variation in the amount of CBD volumes available. Well, again, THC was capped at 10 milligrams. And then we also measured the cannabinoid content in these using high performance liquid chromatography. Moving on, to test this, we first performed an optimization of the enzyme assay using a serial dilution of pure CBD to test the inhibition ability for towards each enzyme expressed via baculosome. And then once this curve is established, we tested a single volume measurement from each of the 18 beverages selected using fluorescent assays to indicate potential or inhibition of each of those cannabinoids. Simultaneously, while quantification was going on using HPLC. And in the next slide, we did a similar experiment with THC beverages. Isolated THC was tested and compared to a selection of 15 beverages. And because there was less of a range of concentrations found in these products, we grouped the beverages by beverage type, including soda, sparkling water, and juices and teas to compare the activity of these groups. And again, quantification was performed. So moving on, I will present the results of these CYP inhibition assays. So first, I'll show the THC. So the line you see here, or the x-axis is the log value of the THC concentration found in each of the tests. And on the y-axis, we're measuring the potential for inhibition. So 100% inhibition means that 100% of the activity of the enzyme has been prevented. The individual points in the green squares are an average of 3 trials from each of the beverages at the same volume using their measured concentration from the HPLC experiments that we performed. So what this shows us, compared to that like solid line of the range of THC isolated, the content of each beverage is showing higher inhibition than expected compared to THC alone. And then moving on to the CBD assays. In the next slide here, so we see this first enzyme here is CYP3A4. So again, the line shows the isolated cannabinoid, the solid line there, this time CBD. And then that's the expected inhibition from CBD alone. And then as we increase the concentration of cannabinoid, we're seeing increased inhibition. But once again, the beverages in the squares are showing higher inhibition potential compared to that isolated CBD sample alone. And then for the next two enzymes we tested, both 2C9 and 2C19, previous literature has identified that CBD has a low IC50 value here, showing that there is a significant inhibition towards these enzymes. And these ones we actually had to lay down. This is a from the initial test, we still see even this range here, we're getting higher than expected inhibition at a lower amount of CBD still compared to the isolated amount. And the same thing could be seen for 2C19 in the subsequent slide. So tying this back to the initial hypotheses of the work in the next slide, so as we increased cannabinoid concentration, we did see increased inhibition, both from the isolated cannabinoid and from the beverages, though that would confirm that cannabinoid presence is driving inhibition in the drinks. To the second point, we did see consistently higher in the beverages inhibition compared to that same concentration of CBD alone. So that would suggest that these beverages have other ingredients or other cannabinoids contributing, but further isolation and testing would be required to attribute this to anything specifically. So the significance of this being that if these cannabinoids are capable of this kind of inhibition, anyone using this beverage or these drinks or these products simultaneously with drugs that are substrates for these enzymes could be potential competition for that enzyme, and activity of the drug or the cannabinoids may be affected. So preventing metabolism, again, could lead to higher drug amounts remaining in the body or decreased activity on either front. And then finally, if there is time, I do have additional slides just discussing the quantification and chemistry side of this, looking at the chemistry of these beverages. So in the lighter color, we see the labeled concentration of these beverages, the expected amount of cannabinoid that should be present in each drink. Well, the dark value is what we in the lab measured using HPLC. So what these results showed is that there's a bit of inconsistency and discrepancy between these two values, sometimes higher, sometimes lower. And this is another part of my thesis that we've are investigating cannabinoid beverage content measured versus actual across products and factors that could prevent these values from being true to their labels. So to summarize in the next slide, what both these components contribute towards from a safety perspective is identifying that these products do present cannabinoid and enzyme potential interactions that could translate into drug interactions. So this work could help inform consumers, vendors, and healthcare workers about how to use cannabinoid edible products in a way that's safe, especially in the instances where consumers also taking medication. So identifying these interactions now can help better product design, safer cannabis use, and better informed decisions made around changing legal requirements of cannabis products. So thank you all very much for your time. And again, thank you to the C45 group for hosting us today.
At this time, we'd like to open the floor to questions. Tom, will you be chairing the questions, or how would you like to proceed?
Yeah, we can both do that together. So yeah, on the behalf of the association, thank you, Philip and Vincent and Corrine, for those lovely presentations. Definitely lots of information to consider. So yeah, we have 10, 15 minutes maybe if people have for questions. I know that we've had a few that were already answered live or during the presentation in writing, and then we have a few more that popped up. So maybe I'll just start with the ones that were answered in writing. Does any one of our panelists or presenters want to kind of reiterate some of those? Because I think maybe there's some additional discussion to be had before we continue the open ones.
Yeah, I think so. I answered some questions. So my study on the environmental impact. So the first question was someone who was asking if this can be applied to indoor growing, and I said yes, of course, because there's already reports of lower nitrogen fertilizer that increases THC. But this is our first report highlighting the importance of the presence of potassium to very boost THC production. So that's something to keep in mind for growers, that the flushing period could be optimized by maybe more potassium. And next question was, did it affect the plant during its life cycle? So the plants that we used was a auto-flowering plant. So because flowering is induced by photoperiodic change, and you can't control photoperiod in outdoor production, right? It's the sun's will or God's will. So we used auto-flowering plants, which is just like they're gonna be ready to harvest in 4 weeks instead of 8 weeks when the photoperiod decreases below a certain threshold. So this prevented issues with early frost or crop failure. So by using auto-flowering plants, we weren't able to discriminate between vegetative and flowering, but it's known that vegetative period, we're gonna need higher nitrogen input, and then in flowering, you're gonna decrease nitrogen input. And the last one was how did you measure ecotoxicity? Well, that's in the life cycle assessment model uses assumption that a certain fraction of your inputs, for example, if you're going to be putting nitrogen fertilizer in your field, it's based on guidelines by an international committee. We assume that 1% of it is going to reach water resources and causes eutrophication, for example. So those were the questions I had.
Vincent, that's great. If I may, I'd like to follow up on that because that's something. This is a topic that's near and dear to my heart. I worked in the cannabis industry for nearly 10 years now on the quality side, and the first few of them were on the indoor kind of cannabis cultivation side. And one of the big projects I kind of worked on at the time was kind of transforming our fertigation to be kind of more science-based and evidence-based. And a big part of it was looking at the NPK ratios and all that fun stuff. And I found the exact same thing. Increasing total nutrients, you get beautiful flowers and buds. Your mass almost doubled. Your yields doubled for the plant weight. But we saw significant THC dilution. And of course, commercially, that's not great, especially when there's kind of this THC war in the industry where everyone wants to get 35% THC, even though that's not generally physically possible. So just to kind of reiterate, and what I've seen in others, do you always want to starve the plant for nitrogen if your goal is for high THC content, or is it more in kind of the later stages?
Yeah, definitely. Because we use the auto flowering plants, we couldn't discriminate between the two stages, but definitely in indoor, what my intuition would be, during the vegetative stage, you want it to be as much fed as possible. And then for the flowering period, then there's room for research, but I'm definitely think that we're just stripping nitrogen but keeping all the other elements, because there has been a very recent paper that highlighted, nitrogen deficiency is going to boost THC and terpene production, right? So I would be really interested in seeing how early you can take out nitrogen of the fertilizer and get the increase in, but I would definitely focus on nitrogen to prevent like nitrogen deficiency response for the plants. And some people say 1 week, 2 weeks before you can start stripping nutrients from the fertilizer. And then people say, oh no, you can keep it up until the end and you just need to focus on your curing procedures, which I'm not sure this is a good idea, but I would definitely look into how early you can start nitrogen deprivation and not see an impact on yield.
Thanks, Vincent. Just a quick comment to follow up on that. So you did your study using autoflower outdoor with soil amendments rather than like inorganic salts, right?
Yeah.
So I guess if you were to replicate this study, or there is potential because to replicate this in an indoor setting using kind of hydroponic based kind of grow systems or like cocoa or peat moss, and you're kind of adding the salts with a more kind of punctuated fertigation schedule. Would you think that your results would change, or is there an appetite to do that? Just because a lot of the time outdoor flower is grown mostly for biomass purposes for extraction here in Canada, but the indoor flower is where kind of really people push the genetics and the potential of the plant and really try to push that content. So is there an appetite for that, or do you see yourself or others kind of doing that, replicating that?
Well, I mean, there's already been, so, you know what, fertigation, the thing is that you are always adding every irrigation event, you're going to have fertilizer. So there has been these kinds of studies where they give a fixed ratio over time, but there hasn't been this time component, like how early can we strip fertilizers in? So I think that would be the next step instead of just replicating what I did indoor, right? Would really be fine-tuning the time component of fertilization. And yeah, I think I've that answers your question, and unless I missed something.
Oh, that's great. Okay, well, let's continue here. We have about more than half dozen new questions, so we'll kind of rapid fire here. This question comes from Aaron. Dr. Philip Addo, is that freezing study published? Do you know?
It is studied. It is published. I just put a link to our publications at the bottom.
Perfect. Thanks, Sarah. Sarah, do you see any questions or panelists that you want to answer?
I'm gonna let Dr. Addo answer the next one, and then we'll keep going. I'm gonna save. Well, I'll just jump to mine, and then I'll let the students talk. Does the program have any students researching QAQC and manufacturing? Well, and could you share some of the research topics? The research topics really depend on our partners. So if there are any, if we have any industry folks approaching us with particular questions in mind, whether it be, labs or industry or trying to make any changes, are they trying to develop standards? We do all of this and we work with people. So it's kind of a broad question that you're asking. I could certainly share if you want to get in touch with some of the things that we're looking at right now. If you want to, I'll put my email in the chat.
Awesome. Thanks, Sarah. And Dr. Addo, I'll read the question for you and you can answer. So it says, Karen here asks, are there any plans to do a cost-benefit analysis on the different approaches to drying cannabis? Most license holders use just a drying room, hang drying, and long cure period. Changing traditional practices may be a challenge. Have you found this to be the case, or did you find your results on moving producers away from traditional hang drying to the other approaches you discussed? So take it away.
Yes. So in terms of the cost analysis, we currently have a study which is still ongoing, where we are basically comparing the energy consumption to do the air or the hand drying compared to the other systems and how you preserve your terpenes and your cannabinoids in your cannabis biomass. So that is hopefully going to be done by the end of summer, and we'll have real-time data based on it. But in terms of convincing these legacy growers on to change their drying systems to the newer one in terms of curing, we currently do have a study evaluating if curing is even important. So if, let's say, I do a freeze drying system, do I even need to cure my product? And that goes back to the same ideology of if I'm able to eliminate a step in my cannabis processing line, I save a lot of money on that. So that answers that question. Now we have the whole idea of, depending on the end product of your cannabis, it's going to determine what kind of processing line you use. So if, let's say, I'm going to say extract my product to develop cannabis oil, I'll prefer to use a freeze drying system and do an optimized extraction process, because in that process, I'm optimizing preserving not only my cannabinoids, but I can also have the chance of increasing some of them. We currently know that there are some enzymes present in cannabis, which when activated can improve your cannabinoid content even post-harvest. So that is the whole idea now, convincing these legacy growers now.
But Philip, what about just the commercial scale and the size of most of these commercial growers and freeze drying as far as like the cost? Like, have you considered that? Do you see that happening anywhere in North America, for example, for cannabis or hemp?
Yeah, so I do know of a company here in Quebec who's got like an industrial freeze drying system where they are able to do freeze drying at large scale. But it all comes down to your cannabis facility and how much biomass you are producing and how quick you need to turn them over. So if you have, say, hectares of land for you to do a freeze drying, it may not be ideal unless you decide to do like a batch system. But for a hand drying system for that would be good. But for pre-rolls, that would be perfect for it. But if you need to go into like a whole extraction system, like do the whole resins, the hash, it would be better to go to like preserve almost everything, which you may lose during your hand drying system, using like a freeze drying process, or even a microwave system where you have a vacuum where you're able to reduce your drying time, because that's a major factor. Because if I'm going to spend 2 weeks to hang dry my biomass where I can do a freeze drying system and only do it in hours, I end up paying for the equipment in the long run.
Yeah, time is money, right?
Exactly.
Thanks, Philip. Corinne, I think there's a few questions directed toward
Yeah,
you.
let's jump to her.
Let's jump
So
to that. Yeah.
The first one is from Terrence Turner. What are some examples of drugs that would be potentially inhibited by the THC products?
The major one of concern is because CBD Epidiolex is marketed as a anti-epileptic drug. So any epileptic drugs that share those pathways have been like a major risk. Those are the big family of concern. But anything that shares those pathways, so like different classes of drugs that are metabolized by those same like major enzymes, like especially like 3A4 is like a huge role in those metabolism pathways. So if there's not alternative pathways, there is risk there. It depends on a drug's like specific breakdown, but I would say, yeah, definitely anti-epileptic drugs are the major class of concern. Sorry, I'm on my phone, so I'm having a hard time switching back and forth between the questions.
And another question directed to you, Corrine. Many beverages advertise as fast onset. Did you study any of these beverages? Any comments on their mechanisms of action?
Okay, so I can comment on this, but in terms of my research, we didn't get quite as far. So in terms of delivery system, I believe this is to do with the like emulsification delivery system and like what kind of carrier oils are involved in the flavorings or the ingredients of these drinks. So I believe in terms of fast acting, that has to do with the type of fat or oil that's that encapsulates these cannabinoids, because they're extremely hydrophobic. So having like MCT or LCT oil as a delivery system allows the potential for chylomicrons or micelles to form. And I believe the fast delivery system is under the premise that these bodies can form and be absorbed through the lymphatic system and then avoid the metabolism in the liver. So that allows a lot more of the cannabinoid to be dispersed through the body. But this is largely dependent on many other things too. Depends on like what else you ate that day. It depends on your body's specific digestive habits. It depends on your body's like specific enzyme makeup. So fast acting has the potential to be fast acting, but there's a lot of other factors. And I believe like a major factor is what else you ate that day. If you have an empty stomach, if you consumed it alongside other liquids. So these things should all be taken into consideration when you read something as fast acting.
Thanks, Corinne. And I think we're at the end of our questions now. And I just have a follow-up for you, Corinne. I like that slide you showed when you're looking at the label claims versus, the test results. That's a huge topic in the industry, has been for a while. We just actually helped support a study on the kind of dried cannabis, and wouldn't you know it, label claims are often a little more inflated than reality.
This is across anything, like not just cannabis, like any kind of standard also needs like external testing. So it would be great to see like through quality assurance and quality control of cannabis, a third governing body that can help like verify these like and get kind of uniform information, instead of having like a mixture of in-house or third-party testing and like inconsistent validation. Like I know there's never going to be a perfect system, but definitely something that is a huge concern for cannabis, but also like just in terms of quantification across any, like the drug industry, natural health product industry as well. So
I mean, some of the results don't look too bad there, and you know, the nice thing is a bit of an update. I've heard as recently as today that inspectors visiting Health Canada cannabis labs are now pushing on the validation on the potency specifically. This is something we've raised, other people have raised, the industry has raised, and so you know, I think the more pressure we put on the industry, and you know, hopefully the better it is. But you're right. I mean, people should not be consuming stuff that's different than what they what appears on the label. So okay, well, we're kind of at our time here. I'll give Sarah and the rest of our presenters here the final word. If there's any final questions or comments they want to add, and then I'll just kind of you know, remind everyone about the summit there. So Sarah, is there anything else you wanted to discuss? Or?
Nothing. I'm just thank you for giving this platform to share our work. These are certainly these two PhD candidates and Philip as postdoctoral fellows. They've been here from the very beginning, but we have 25 other active researchers that will be presenting their work in June. So you're welcome to attend. And if you have your own R&D questions that you'd like to present or data that you find interesting that you're willing to share, you're most welcome to. It's been a pleasure kind of, you know, being at the forefront of research in this nascent industry for many of us. We're looking forward to next steps and seeing how it all comes together as it all plays out.
Yeah, this is very important what you're doing. I think you know, there's a lot of lore and mythology in cannabis production, especially the cultivation side of things. And I think a science-based approach to cultivation in a multi-billion-dollar industry, you know, is very important. So, you know, the fact that you and your kind of network there is tackling these issues head on is very important. So I encourage any of our listeners to reach out to you. To you know, maybe they're students and they want to look at the program, maybe they're industry partners, they want to partner up. I think there's always opportunity there. So thanks again, Sarah, Philip, Vincent, and Corrine. You guys were wonderful. Thank you for your information. Good luck at this session. And I'll remind everyone that we are also hosting that same week. So maybe you can do a road trip from Montreal
Absolutely, to Eastern Canada.
Hamilton. You know, a whole
Yeah.
week of cannabis science and quality in Hamilton, Ontario. We would really love to see all of our friends and supporters and members and industry partners out there. Please check us out, c45summit.com. Become a sponsor, buy a ticket, $99 now. They're going up over the next few weeks and months as we get closer. So secure your spot, get a membership, and keep supporting us. So thanks, everyone. Good luck out there. And if there's an opportunity to do this again, we'd love to host you.
Great. Thanks so much.
Thanks. Take care.
Thank you.